I'm starting challenge 2, the dilutions. I have my 20% stock solution, my water, and then my 25 milliliter volumetric flask, and my 10 milliliter pipette with my bowl. I'm going to draw up some of my stock solution. My initial volume is at about 3.15. I'm going to deliver some of this into my volumetric flask. My final volume is about 9.1. I'm now going to dilute my stock solution with water up into the 25 milliliter mark. And as you can see, that meniscus is right on that 25 milliliter mark.
And now that we have our solution in here, I'm going to go ahead and take it over to the balance and measure it.
As you can see, I did all the math and I got the concentration of my first dilution and the density of my first dilution. I'm now going to dump my dilution 1 into this empty beaker to use for my dilution 2. I'm now going to draw up some of my dilution 1 to transfer in my volumetric flask to use for my second dilution. My initial volume is at about 5.25, as you can see here by the meniscus. I'm going to transfer some of this into my volumetric flask. My final volume is at about 9.19, as you can see here on the meniscus. Now I'm going to use water to dilute my dilution 2 up to the 25 milliliter mark.
As you can see, I'm further diluting the already diluted stock solution in the flask. A stock solution is a concentrated solution of a known concentration that will be used for diluting. The diluted solution is a solution where water has been added to a certain amount of the stock solution in order to decrease the concentration and therefore dilute the stock solution. The dilution equation is M1V1 equals M2V2. M1 and V1 represent the molarity and volume of the initial concentrated solution, and M2 and V2 represent the molarity and volume of the final diluted solution.
So now we are going to go ahead and put it on this balance, and we're going to get this final mass real quick, which is 44.096.
As you can see, I did all the math and I got the concentration of my first dilution and the density of my first dilution. Now I'm going to take my dilution 2 and pour it in an empty beaker to use for dilution 3. Now I'm going to draw up some of my dilution 2 to use for my further dilute for my dilution 3. As you can see, that meniscus is right there at about 7.1. I'm going to transfer some of this into my volumetric flask. My final volume is at about 9.15. As you can see, the meniscus right there. I'm going to further dilute my dilution 3 with water up to the 25 milliliter mark. You've probably heard the word meniscus mentioned multiple times in this video so far. The meniscus is the curve at the surface of a liquid in glassware. It is caused by the cohesive forces between liquid molecules and the adhesive forces between the liquid and the walls of the glass tube. This is also known as capillary action. In order to read a meniscus, you measure at the center of the curve that is formed, in this case, the bottom of the meniscus. The next clip is an example of the meniscus hitting right at the 25 milliliter mark on the volumetric flask.
Okay, we are back at the balance to measure that mass. Let's see what we get. 44.018.
You can see from my math that my C1, I used the concentration from my last dilution, and I got the concentration of my dilution 3, which is this right here, and then the density of my dilution 3 right here.